Hello there. In this recording, we talk about a key skill you need to be successful in your studies in math. It's called factoring, and we're going to apply this to algebraic expressions. So, what do we mean by factoring? Factoring means to write an expression as a product of two or more factors so that the final expression is a product. That means one thing multiplied by another thing. This idea comes from numbers, dealing with real numbers. For example, 6 in factored form can be written as 2 multiplied by 3 because 2 and 3 are factors of 6. Another example is 28. 28 can be written as 4 multiplied by 7. 4 and 7 are factors of 28. You can even split this further and write 28 as 2 times 2 times 7 because 4 is 2 times 2, so that you have 3 factors now multiplying one another to give you 28. That is what factoring is. Now, to do factoring properly, there is the idea of the greatest common factor of two numbers or two expressions. So we're going to talk about that. How do you find the greatest common factor of two numbers or two or more numbers? For example, 12 and 18. What is the greatest common factor of these two numbers? What we have to do is to find out the factors of 12 and the factors of 18, and then figure out the factors that are common to both numbers. We will then select the greatest of those factors or the biggest of those factors. So what are the factors of 12? Well, they are listed as shown: 1, 2, 3, 4, 6, and 12. The factors of 18 are 1, 2, 3, 6, 9, and 18. What are the common factors here? You can see that the common factors are 1, 2, 3, and 6, and the biggest one is 6. Therefore, we will say that the greatest common factor of 12 and 18 is 6. Let's try three numbers: 30, 20, and 15. We will do the exact same thing that we just did. What are the factors of each of these numbers? Let's list them. If we list the factors of 30, 20, and 10, they are shown here. The common factors are circled in black, and since the common factors are only 2, 1, and 5, the greatest one would be 5. Therefore, the greatest common factor of 30, 20, and 15 is 5. Can we do this with algebraic expressions? Because that's really where we're going. We want to be able to find the greatest common factor of algebraic expressions. Well, the answer turns out to be yes. And I am going to be showing you how to do that in the next slide. So let's look at these two terms: 10x squared and 18x cubed. From your study in your previous math course, I hope you can recognize that these are monomials. They are polynomials that have only one term. You can see the exponents, they are whole numbers, 2 and 3. There are no roots there, there are no negative exponents, there are no fractional exponents in there. So this is a monomial. It's an example of a polynomial. So let's factor this. Like we did previously, this time though, because we are talking about an algebraic expression, we start with what we call the coefficients. The coefficients, like we learned in your previous math course, are the numbers attached to the variables. So in this case, the coefficient of 10x squared is 10, and the coefficient of 18x cubed is 18. So we start by factoring those two numbers, which we just went through. We list the factors of 10 and 18, and we select the common factors, and we choose the biggest one of those common factors. So the greatest common factor of 10 and 18 is 2. And then we go to the variable part. In this case, x squared and x cubed. Now, whenever you are talking about variables that look like this, where it's just the exponents that are different, you have x, and then you have squared and cubed, the greatest common factor is always the variable with the lower exponent. So therefore, the greatest common factor of x and x cubed is x squared, is the greatest common factor. So we then combine the greatest common factor of 10, the coefficient 10 and 18, which are the coefficients, with the greatest common factor of the variable part, x squared and x cubed. Therefore, the greatest common factor of 10x squared and 18x cubed is 2, which is the greatest common factor of the numbers, the coefficient, and x squared, the greatest common factor of the variable part. So we have 2x squared as the greatest common factor of 10x squared and 18x cubed. Now let's combine terms. So 3x plus 12. You will recall again from your previous studies that this is a binomial. It has two terms in it. It's a polynomial with only two terms, and you can see that this is a polynomial. The exponent of the x is 1, and the other term is just a number. So that's a binomial. It's a polynomial with only two terms. Can we factor this expression? Can we rewrite an expression like this as a product of two things? Well, we're going to try. Well, to do this, we are going to have to look at the two terms and factor them like we did previously. So we start with 3x and then we go on to 12. And we start with the number, the coefficient, which is 3. And on the other side, we have only one number there, which is 12. So we can start with that number 2. So we'll take the factors of each of those numbers. The factors of 3 are 1 and 3. And the factors of 12 are 1, 2, 3, 4, 6, and 12. The common factors are 1 and 3. And the greatest of these factors is 3. So the greatest common factor of those two terms is 3. You only have a variable with the 3, right? The 3x. The 12 has no variable with it. So therefore, the greatest common factor there will be 1. So we are not going to be having a variable in the greatest common factor. Therefore, our greatest common factor here is 3. Now, what we then do is write the 3 and open a bracket. And then inside the bracket, we divide each term in the bracket by the greatest common multiple that we just found. The greatest common multiple we just found is 3. So we will divide 3x by 3. And we will also divide 12, which is the other term in the expression. We divide that by 3. If we simplify these divisions, we will obtain 3 multiplied by x plus 4, because 3x divided by 3 is x, and 12 divided by 3 is 4. That means that 3x plus 12 is the same thing as 3 multiplied by x plus 4. You can see that 3 multiplied by x plus 4 is a product of two terms, kind of like factoring 6 into 2 times 3, or factoring 28 into 7 times 4. So you see that you have this multiplication there. This is the factored form of 3x plus 12. So we have factored this. And we know that we are correct, that our factoring is correct, because if we redistribute the 3 into the bracket using the property of multiplication as being distributive over addition, you will see that you will obtain 3 times x, which is 3 times x, which is 3x, and 3 times 4, which is 12. So these are the same things. Let's do another example. 4a squared plus 8a. Again, this is a binomial. You can see that it has two terms, and it's a polynomial because you can see the exponents of the variable. They are non-negative, they are not rational, there are no radicals. You're not having the square root or the cube root in there, taking the cube root or the square root of the variable expression in there. So it is a polynomial. We'll do the same thing like we did previously. We start with the coefficients and find the greatest common factor of the coefficients. After finding the greatest common factor of the coefficients, we also find the greatest common factor of the variables as well. In this case, the greatest common factor of the variables will be a. So therefore, the greatest common factor of 4a squared and 8a is 4 times a. We then write 4 times a outside the bracket and divide each term in the bracket by the greatest common factor that we just found, which if we do here, we will obtain 4a times a plus 2. And if we redistribute 4a into the bracket, you will obtain the original thing you started with. Therefore, we are correct. What about an example like y to the power 7 plus y to the power 11? The coefficients here are 1, so the numbers there are just 1, so the greatest common factor is 1. There's no need to worry about that. But you have y to the power 7 and y to the power 11. The greatest common factor will just be y to the power 7 because that is the one with the lower exponent. If you write that outside of the bracket like we've done and divide the two terms in the bracket by the greatest common factor we just found, we will obtain y to the power 7 multiplied into 1 plus y to the power 4, which if you redistribute, you will just obtain the original thing you started with, which means our factoring is correct. Let's do one more example here. Negative 6x to the power 4 plus 12x cubed minus 3x squared. If we do what we just did previously, here now we have three terms. The coefficient of each of those terms, negative 6, 12, and negative 3, well, we can just ignore the negative for now and just think of 6, 12, and 3. The greatest common factor there will be 3. And x to the power 4, x cubed, and x squared, because the variables, the one with the lowest exponent is the 2, so the greatest common factor there will be x squared. So the greatest common factor of the three terms in this expression, which is a trinomial, it's a polynomial with three terms, is 3x squared. And then we can open a bracket and divide each term by the greatest common multiple we have just found. If you divide negative 6x to the power 4 by 3x squared, you will get negative 2x squared. If you divide 12x cubed by 3x squared, you will get 4x. And if you divide negative 3x squared by 3x squared, you will obtain minus 1. Now, whenever the leading coefficient, that is the coefficient of your first term, whenever that is negative, it is usually preferable to factor a negative out instead of having the 3. You will just factor the minus 3 out from there. And the only difference will be that the signs will change in the bracket. So instead of having negative 2x squared, you will have 2x squared. Instead of having positive 4x, you will have negative 4x. And instead of having negative 1, you will have positive 1. And if you redistribute into the bracket, you will obtain the original thing back. That means your factoring is correct. Now you try and see if you can find greatest common factor and do some factoring here. Like as previously, please pause the video as soon as you can see these questions, and you can try to solve the questions, and then afterwards you can restart the video to see what I have done. So go ahead please and pause the video now. So what did you do? Well, I'll show you what I did here. Starting with the numbers like we did previously, if you have your 18 and 24, you have to find the factors of 18 and 24 and identify the common factors, and then out of the common factors choose the biggest one. If you do that here, you will see that the greatest common factor of 18 and 24 is 6. Similarly, for 12 and 28, you can figure out the greatest common factor in the same way by finding the common factors and identifying the biggest one among them. And then when you have the variables 12x and 30, you can do the same thing. You start with the coefficient. You have the coefficient of 12x is 12, and then you have the constant, which is 30. It's just a number, right? There's no variable there. So in this case, you will see that the greatest common factor of 12 and 30 is 6 if you follow our process that we have identified previously. And therefore, the greatest common factor of 12x and 30 would be 6. And then what about this binomial that you have here, 6y squared plus 15y? We will do the same thing by starting with the coefficient 6 and 15. The greatest common factor of 6 and 15 is 3. And then y squared and y, the greatest common factor there will be y, which if you write outside of a bracket and divide the terms inside the bracket by the greatest common factor, you divide 6y squared by 3y, you will obtain 2y plus 5 as shown. And if you expand, you will obtain the original thing back. So we're correct. And finally, we do the same thing with negative 12x cubed minus 4x squared. We will factor out the negative in this time. So we will have the greatest common factor of 12 and 4, which will be 4. But then instead of having to factor 4, we'll factor negative 4 because the leading coefficient is negative. And if you do that, and we'll do the same thing with x cubed and x squared, the greatest common factor there will be x squared. And if you factor out negative 4x squared by dividing each term in our expression by negative 4x squared, you will just obtain 3x plus 1. And if you redistribute back into the bracket, you will obtain the original thing we started with. So we are correct. So this concludes our initial video for factoring.